All right, you maggots, listen up. A few videos ago, uh, I took let's see what number it was, a T50-43 uh, toroid coil, ferret toroid coil, and same circuit. Now I have in an FT82-61, which when you test it with the tester, the cheap eBay tester, it actually detects a Q factor of 12. The other one, it showed nothing. Is this it here? Yeah, here it is here. Now, when I did do this coil, I had 6 turns to the output. So this coil here, say it has 50 turns on it. Use the formula or the program on Torroid's info. And this is set up, this coil is, I said it's an FT82-61, and it's set up to be a crystal radio toroid coil. It does the AM broadcast band. So coming in is an antenna to the top of the coil. The coil's across the capacitor, just one section. The bottom goes to the chassis. The bottom of the coil goes to the chassis, which there's a black wire that goes over to the electrical socket and gives me ground. And there's 6 turns of wire that goes off to shielded wire over to my DX390, and it's going into the side of the radio, and there's no amplification. It's cutting out the ferrite rod in the radio. So I'm going to turn it on. It's going to be really noisy because I have the LED light on, and my computer is on, and you know how AM broadcast is. So anyway, we turn it on, and now we're gonna move this capacitor, and you're gonna hear the radio peak up at that frequency. And notice the peak is I'd say the peak is within a 1/4 inch of movement. Now, when you use the FT50-43, I might have said it wrong before, but in other words, this is a wideband toroid coil. It's good for making a mixture of 2 different signals, and it does a wide range of signals. But it will peak up with a capacitor, but it's very muddy. So, and it shows no Q. So when you have Q, you get the coil becomes more excited when it's hit with a signal and it's at resonance. When you tune it through the resonant frequency, it's sharper when you have more Q, and that will give you less, better noise to signal to noise ratio. It's always good in a radio to have good Q coils. It just gives you so much more. Now, I always pick on those SDR radios. They use 1 ferrite bead as a bandpass filter for like 4 bands. They're just kind of in there on the circuit board. Now, a good bandpass filter has good ferrite toroids in there. It's got capacitors, and you adjust it for the middle of the band. So say you're doing 80 meters. You would tune it for 3.5 megahertz, and then any frequency on either side will get through to a certain width, a certain band. It's a bandpass filter. It blocks out anything else that's not in the area of 3.5. So in other words, you move it from 3.5 to the center of the 80 meter band. So just for rule of thumb, just say 3.5, and any frequency outside of that area gets shunted out or gets attenuated. Right? So when you use a toroid coil, you want to use the right one, the right formula mix, and you want to have good Q. Now, when you look this up on Torroid's info, which this is a FT50-43, it's good for mixers. It never mentions the word Q. Other coils, basically, it has a little footnote in there, and it says basically high Q when within the frequency range that they show you it's a program that you can enter the amount of capacitance you're going to use, what frequency you want, and it comes back with how many turns. In other words, but you put in the capacitance you're going to use, and what frequency you want. And it comes back with how many turns, and then you can use it to. My capacitor goes between this range and that range. You got to put a couple different numbers in, and run the program, and then you get an idea of what your capacitance range has to be, and your turns that you're going to need for that frequency. There's a learning curve involved, but I want to tell you this is a FT 82-61. I found it on a transmitter. Guy says build this transmitter, and he figured out to use the FT 82-61 in the AM broadcast band. And then when I saw that, I ordered some. And I told you, this coil here is from the that circuit I recommended, Crystal Radio circuit. And this is the first coil where you come in off the antenna. It's got a center tap. Go look at the circuit. I know some of you are like, hey, you should have mentioned the circuit. You got to go look. There's one circuit that I mentioned as being the best circuit to start with. And it is the best, but I didn't want to say that. I just want to tell you, start with that circuit, and you'll realize a lot of Crystal Radio circuits aren't as good, and then try to find one that's actually better. And when I built it with the coils they tell you to wind, I used a Litz wire, worked very well. And then I said, let me now, because it's done in such a way, this coil, instead of going to ground, it goes to 20 turns on the next coil, then to ground. And the next coil's got it is a tuned circuit in the AM broadcast band, but the induced signal from the first toroid coil then goes through the second toroid coil to ground, and it steps up, and then that's how you couple your signal into your second coil. See, the best Crystal Radio circuits have two coils. There are a lot of them. There's the Australian Mystery Radio only uses a single coil. Fine, that's good. But if you want to do real DX and you want a really good Crystal Radio, you got to have two separate coils. You got to have a really good set of headphones. I don't mean Bose headphones or something like that. I mean like Brandy's 2,000 ohm Crystal Radio headphones, and you're gonna have to recharge the magnets. I showed you how to do that on one of my videos. You can get a pair of trim Crystal Radio headphones on eBay. They're like these things are almost 100 years old, and they are made for very faint signals from a Crystal Radio. And then Crystal radios, once transistor radios or tube radios came along, and transistor radios come along, Crystal radios became like a toy for kids, and they used that little stinky little. It used Rochelle salt in it. Now it uses a piezo element, which doesn't work that good. See, a lot of these Crystal Radio circuits, they do work when you're close to stations. But when you want to DX late at night, your coils have to have high Q. You have a good set of headphones. You got to have 250 feet of wire for the antenna. You got to have a good ground rod, and you'll get a lot of stations. I won't say you can log all 50 states, but you should at least get 25 states late at night, and they'll fade in and out. It's a hobby within itself. All right, but I just wanted to show you how much tighter a coil that has Q. It has a Q of 12 on this thing. All right, so it might have a Q of 50 in reality, but this at least lets you know what amount of Q you have, and then when you wind another coil, you can realize the coil you wound is better than the one you got. See, it's a reference number. It's for experimenting. But, I knew this would peak up because the Torroid info, that little program, it said I would need a certain amount of turns. Actually, there it is over here. I take it back. It's this one over here. 15 turns. All right. This one here is a T50-1, and it needs 100 turns, and I could only get 46 on it. That's when I originally started buying these, because they're bigger and I could put more turns on it. Plus, it's a little more denser. It's basically 40 AM broadcast band, where a T50-1 might be 250 kilohertz to 3 megahertz, something like that. And then there's T50-2. You got to go read up on all this stuff. I'm still looking for a definitive book on toroid coils, and I haven't found it. I told you, when toroid coils became popular, it's just about the time like Don Lancaster stopped writing new books. And I think Jung is the other guy that wrote for Radio Shack books. They didn't cover it that I know of, toroid coils. And then I got into toroid coils, and it's piecemeal. You go read about a circuit, and the guy sort of explains something, and you get it in your head. And then the things you have to understand is they're different sizes physically, but they're also different mixes of ferrite material. And then as you go lower in frequency, ferrite is the oxide. And then you mix some more iron with the ferrite, and you bring the frequency down. And you can't use the coil or the ferrite blank for high frequencies anymore. It's only good for lower. And this one here, when they use the number 61, that's used in ferrite rod antennas. 61 it's telling you broadcast band. There's stuff that, it's not in any book. It's just a matter of, when you work with it long enough, you catch on to some of the stuff. That's why when you got these guys out there, I knew that. Where's your video? I think that's it. All right, that's it.